Welcome to Electriverse channel. Hello. Today we are going to dive deep into a very interesting and important topic. Variable speed drive or VSD. If you are an electrical engineering student or a professional working in the industry, this topic can prove to be a game changer for you. Today we will understand VSD from zero to hero level. We will explain each component, each function, and the latest technology in such simple language that you will have no doubt after this. So let's get started. First of all, the question arises, what exactly is VSD and why was it needed? Look, in our industries and homes everywhere, electric motors are used, from water pumps to large machines. Traditionally, these motors run at a fixed speed. Imagine you need to run a fan, but it will always run at full speed. Even if you want low speed, it still runs at full speed. How much energy will be wasted because of this? VSD. This is the solution to this problem. It is an intelligent device that controls the power supply to the motor, adjusting its speed according to our needs. And its biggest benefit is energy savings. You will be surprised to know that in HVAC systems, that is, cooling systems of large buildings, if the fan speed is reduced by just 20%, approximately 50% of energy can be saved with the help of VSD. 50% is a very significant number. Now you might be wondering how this magic happens. For this, we will have to look inside the VSD. A complete setup of a VSD consists of four main components. Understand these well, because they form the foundation of VSD's working. The first component is the rectifier. Its job is to convert incoming AC power, which comes from our supply, into DC power. You can think of it as the gatekeeper of the VSD, which takes AC power and converts it into a different form, namely DC. Now this DC power that is generated is somewhat unstable. It experiences fluctuations. Here the role of another component comes in, the DC bus or DC link. The DC bus acts like a reservoir. It stores the rectified DC power and filters it to produce a completely smooth and stable DC voltage. Its job is to prepare a steady supply so that the next stage can operate properly. You can call the heart or magician of VSD here. The inverter takes that smooth, stable DC power and converts it back into AC power. But here is a twist. The new AC power generated here is not normal AC power. The frequency and voltage of this alternating current power can be controlled as per our wish. And as we know, the speed of an AC motor directly depends on the frequency it receives. Increase the frequency, increase the speed, decrease the frequency, decrease the speed. And who controls all these? Fourth component, control circuit. This is the brain of the VSD. This microprocessor-based circuit takes commands from the user, receives feedback from the motor, and guides the inverter on how much alternating current power in terms of frequency and voltage needs to be generated for the required speed of the motor. The process is simple. AC to DC, smoothing the DC, and then converting the DC to controlled AC to power the motor. But how does this inverter convert direct current to controlled alternating current? Here, a very popular technique is used called pulse width modulation or PWM. Let's understand it in simple language. Imagine you have a water pipe with a tap. You need to control the water flow. One way is to open the tap halfway or less. PW, Ims duis sancham different. PWM turns the tap fully on and fully off, but very rapidly, suppose thousands of times in a second. Now, if you keep the tap on for more time and off for less, the average water flow will be higher. And if you keep it on for less time, the average flow will decrease. The inverter does exactly the same. It rapidly switches high-speed DC voltage switches on and off, creating a series of pulses. By adjusting the width of these pulses, that is, the on time, it controls the average voltage and frequency supplied to the motor. That's why it's called pulse width modulation. With this technique, very precise control of motor speed and torque is achieved. Now let's talk about its applications. Where are VSDs used? To be honest, in today's modern industry, there is hardly any place where VSDs are not being used. In the manufacturing industry, VSDs are used to match the conveyor belt speed with production demands. In mixers and grinders, speed control for consistent product quality is achieved through variable speed drives. In water treatment plants, the pump speed is controlled to manage flow and pressure, preventing water wastage and saving energy. In the mining industry, large crushers, mills, and conveyors are controlled with VSDs to optimize material processing. And of course, we have seen the HPCS system, whereby controlling the speed of fans and pumps, energy savings of 20 to 50% are achieved. Technology is always advancing, and VSD is no exception. Today's VSDs are much more advanced than before. A major advancement has occurred in semiconductors. Previously, traditional silicon-based components were used in VSDs. Now, they have been replaced by wide bandgap semiconductors such as silicon carbide and gallium nitride. The advantages of these new materials are that they can operate comfortably at high voltages and high temperatures. They have very low energy loss, and as a result, the size of VSDs has also become smaller, meaning more power in a small package. Control strategies have also become very smart. There is a technique called Model Predictive Control, or MPC. It is an advanced control strategy that gives VSD the power to predict the future. By using the mathematical model of this system, it anticipates upcoming load changes and proactively adjusts the motor speed. This improves both the performance and efficiency of the system. And the biggest trend is IoT integration. Today's VSDs do not work alone. They are connected with the Internet of Things. This means you can monitor your VSD from anywhere in the world. You can see its real-time performance and track its health. If there is an upcoming problem in the VSD, you get an early alert through predictive maintenance. But yes, there are some challenges with this integration, such as data security, compatibility of different devices, and integration with legacy systems. Now, let's move on to a very practical aspect: safety and maintenance. VSD not only saves energy, but also enhances the safety of the motor and the entire system. VSDs come with several built-in safety features: overcurrent protection, overvoltage, undervoltage protection. Overtemperature protection is equipped with temperature sensors inside the VSD. If the drive starts overheating, it either reduces the load or shuts down. And most importantly, VSDs provide soft start and soft stop. This means the motor does not start suddenly at full speed, but gradually reaches the desired speed. This significantly reduces mechanical stress on the motor and machine, increasing their lifespan. However, to enjoy these benefits, proper care of the VSD is essential. Maintenance is very important. Regular visual inspection is necessary. Check whether the cooling fans are functioning properly. Ensure there is no dust on the heatsink. All electrical connections should be tight. Loose connections are a major cause of overheating, and VSD should always be installed in a clean, dry, and well-ventilated place. A common issue that comes with VSD is harmonics. The switching action of VSD causes noise or disturbance in the electrical system, which is called harmonics. These harmonics can disturb other sensitive equipment. To avoid this, harmonic filters are used. VSD. Ultimately, VSD is a very essential part of modern industrial applications. It increases energy efficiency, provides better control over processes, extends equipment life, and enhances system safety. Whether you are a student learning about motor drives or a professional looking to improve your plant's efficiency, a deep understanding of VSD will prove to be very beneficial for you. If you liked today's video, please like, share, and subscribe. It motivates us to create more such fantastic videos. You can also tell us in the comments what topic you would like the next video to cover. You've been watching Electriverse, where every spark tells a story. Stay charged, stay safe, and happy.